Hi, good morning. This is the Gardener community meeting. Today we have two topics on the agenda. First, we have George, who will be talking about Etcd-druid, which is a controller to manage Etcd. And then we have Gaurav with HVPA controller. George, I can see your presentation.
So do you see the slide
Yes,
or the app? So
I
you
see
see
the
the slide, right?
slides.
Okay, cool. So I hope it's not showing all the slides as in the app. It's showing the actual presentation
Yes,
view.
I see the title now.
Cool. Okay, so yeah, let's start with HVPA controller. I have put the link also in this. So basically, let's start with what it is exactly. So and what it does. So this scales the Kubernetes applications, and it scales horizontally. It scales applications vertically, and it scales an application both horizontally and vertically. So let's see what we have right now. Before HVPA controller was in the picture, how we were used to scaling our applications. So this talk assumes that you have the preliminary knowledge about HPA and VPA. I'll just introduce them for a minute. So uh, the working of HPA and VPA can be divided into mainly two parts. Part one is to provide recommendations based on the application's usage of CPU resources or any other metric, for example. And part two is responsible for using those recommendations and scaling the workload, be it deployment or stateful set. So best illustrated by using an example, deployment. And if we have an HPA deployed, then it will just scale the vertically scale the deployment or an application horizontally. Let's say the CPU requirement was 3 times or memory requirement was 3 times, so it will just scale it 3 times. Or in case we have only VPA deployed, in that case it will just scale the application vertically 3 times. So just for an example, right? Now, what if we deploy both of them together, and if we have an application which can scale both vertically and horizontally, uh, and the resource usage can be best optimized when the application does that, basically scale both horizontally and vertically. Uh, but what we have found out is that HP and VPA don't mix well together, and there are some limitations with these autoscalers that we'll see later. So, for example, we have that application which we want to scale horizontally and vertically, and the requirement or the usage increases to 3 times. So now the horizontal pod autoscaler and the vertical pod autoscaler both will want to scale the deployments both vertically and horizontally, and the VPA kicks in and it increases the deployment size 3 times, and then HPA also kicks in and then increases the number of replicas to uh, as recommended by HPA, and suddenly we have 9 times the total requirement, um, 3 times the total requirement, which is not an ideal situation. Uh, another another limitation with using HPA or VPA or both is that once they are deployed, the user get little control over the scaling. So, for example, per resource or per HPA or VPA, we cannot set a minimum threshold. Only above which, if the delta is there, only then the scaling happens. Even if there's a small recommendation change, the scaling will happen, which might not be an ideal scenario in which, in cases uh, when, for example, VPA, in case of vertical scaling, deployment might go through rolling update, and if that happens, and if that happens for every small change, then it might be disruptive to the application. So this kind of freedom is not there, for example, with VPA. With another kind of limitation is that we cannot set the kind of scaling that we want. That if a user wants only scale up or scale down, it is not possible by using HPA or VPA. Uh, the third one is to give a user freedom to set the scaling time to a particular time window. So, for example, if a user only wants scale down during maintenance window and not any other time, uh, this kind of feature is not provided by either of the autoscalers. So we'll see how HVPA solves these problems. What HVPA does is it takes the control and gives it back to the people. And this is a boon of HVPA, which we can utilize for scaling our applications. So let's see how HVPA can do that. So what it does is it takes half of VPA. It doesn't use full capabilities of VPA. It uses half of HPA. It adds them to, and it adds its own magic to get. So that's how we get an HVPA controller. So let's see. Let's dive into more detail on how this magic works. Uh, so let's see how we can use half of VPA. So as I said, these autoscalers can be divided into two parts. One is the recommender part, and the other is the updater part, which is responsible for actually using those recommendations. Uh, for HVPA, since HVPA takes the control of updating uh, the application, we only need the recommender part of the VPA, and HVPA controller itself creates the VPA that is required to get the recommendations in an off mode. Uh, since VPA supports an update policy or update mode that is off, in which case the VPA will only set the status of the VPA resource to the new recommendations. But since VPA updater is turned off, uh, because of the update mode, it will not apply those recommendations, which this job is overtaken by the HVPA controller. What about HPA? How do we take half of HPA since HPA doesn't support update mode as of now? So what I did, so we decided that we can join the auto scaling group and propose some spec changes so that even update mode can be provided in HPA spec so that this part can be switched off. But there were some reservations regarding changing the spec of HPA, uh, but the community suggested one idea. Uh, the idea is that so let's see how HPA works to get into the details of that new suggestion. So as of now, HVPA targets the deployment or the applications, and HVPA also creates an HPA resource. This HPA resource is supposed to target to the deployment so that it can get the usage. But since we don't want HPA to control the deployment directly, what we can do is and how HPA scales the deployment is using the scale sub resource that a deployment or, for example, stateful set also implements. So what we can do is we can point the HPA to the HVPA and make HVPA implement a scale sub resource. So HPA can directly update the HVPA's replicas, and then in turn, HVPA can scale the deployment or any applications according to certain policies set on it. So this is how we take half of HPA. So let's see what is the magic part of HVPA controller. So this is the spec. Under spec, we can provide the HPA spec, basically the HPA template, which will have certain policies governing how horizontal scaling can happen. We'll get into the details of that later. Similarly, we have a VPA template which has the details of for VPA. Then we have a target ref, which is pointing to the application that we want to scale. We have this new field weight-based scaling intervals that we'll get into details later, and we have another field called maintenance window, which is obvious by the name that this is the maintenance window during which the update policies, if set to maintenance window, then only scaling will happen. So let's dive into the details of each of these fields. So there is one capability into HVPA built in that is setting update policy for individual scaling, both horizontal and vertical in all the directions, but that is up and down. So these update policies can be set to either maintenance window, for example, so in which case the scaling in any direction will happen only during maintenance window, which is a part of which is specified in the spec of HVPA controller, HVPA resource, or the update policy can be auto, which will mean that the scaling will happen as and when the recommendations come in, and certain other parameters like stabilization window that we'll get into later are also satisfied. Or the update policy can be set to off, in which case we'll only get the recommendation, but that recommendation will never be applied. So another kind of spec field is stabilization duration, which is also applicable for all kinds of scaling, that is horizontal, vertical, and in both direction, up and down. So this stabilization duration can be given in seconds, minutes, or hours. So what it would mean is that it would restrict the consecutive scaling for that stabilization duration amount of time. So if the scale down stabilization duration is given, for example, 3 minutes, in that case, it needs to be at least 3 minutes at least needs to be passed if a scale down is recommended by VPA or HVPA, for example. Third kind of spec field is a minimum change threshold. So as I said earlier, this is the threshold below which no kind of scaling will happen. So for example, if a VPA scale down minimum change, the value for that is given as 3 for the CPU. In that case, only if the vertical recommender, VPA recommender provides a recommendation that is more than 3 CPUs, only then the scale down will happen. And similarly, the value can be given in percentage. So the delta should be at least 80% of what is currently set on the deployment. And similarly for memory, these values can be given. And same thing, this can also be given for both scale up, scale down, and even for horizontal scaling based on number of replicas for HVPA. This also has the capability of governing how the limits of a deployment or stateful set are scaled, not just the request. So the parameter is called limits request gap scale parameter, and even in that case, we can give let's say a CPU percentage, that the gap between the request and the limit needs to be 80% of the request. Or a absolute value can also be given. So basically, it will always be at least 2 cores difference between the request and the limits. And similarly for memory, both the values can be given. Now let's see how all of these things come together to form a spec. So this is an example of a scale down. Let's say this is given to a VPA part of the spec, and this will govern the. So what it does is that it sets the update mode to maintenance window, and so the scaling will happen only during the maintenance. So scale down will happen only during maintenance window, and scale up can happen at any time given its update mode is set to auto. And stabilization duration and min change. So when all of these parameters are satisfied, only then scale down will happen. Another example, so for scale up, let's say update mode is set to auto and stabilization duration is set to 2 minutes. In that case, scale up can happen at any time given that 2 minutes has passed from the last scaling. And also the minimum change in CPU and memory is 3 cores. And sorry for the misprint here, the memory is not 3, but maybe 3 GB or 300 megabytes or any value which is valid for the memory. So let's see how these can come together, right? So let the scale down is set to maintenance window or off, in which case the scale down will happen only. So it can be either of the two values, right? So scale down will never happen, or scale down will only happen during the maintenance window. And the scale up can be set to auto. For example, with the stabilization duration of 2 minutes and some values that we find, right? So it is left to the user to judge what these values are. And set these values accordingly. Now, does anyone have a question till now? Any questions? Then I can move forward otherwise. Okay, I guess not. I am audible, right?
Yes.
Yes.
Hello.
Yes, okay. You are audible.
Thank you. So let's move to the next interesting part of the spec, which is weight-based scaling intervals. Um, so what it does is, so what a user can specify is, so it, how much weightage it wants to give to any of the recommendations. So for example, in the first part, we see that the start replica count and last replica count is 1 to 2. So if the current number of replicas running for the application is between 1 and 2, including 1 and 2, then the weightage given to the VPA recommendations will be 30%, and the weightage given to the HPA recommendations will be 70%. So in this way, we can control the the way both HPA horizontal and vertical scaling can happen on an application. So this will prevent us from deploying 9 times or 3 times of the deployment that we had seen earlier when HPA and VPA are deployed independently. So similarly for when so this is an array. So if the replica count is between 3 and 7, then the VPA weight can be a different based on the user's requirements. And if the start and if the replica count is between 7 and 10, then even a VPA weight can be given to 0, in which case it's a purely horizontal scaling. So any kind of value can be given here. So this way we can control how an application can scale both horizontally and vertically in an optimized manner. So this is another example where so this is how we are currently anyway scaling our HVPA server also, because there are certain limitations. HVPA controller is not complete yet. There are more features being added, like the scale sub resource uh, that we had talked about for HPA. So this is an example where the initial scaling from 1 replica to 3 replicas happens only horizontally, since the VPA weight is given 0. And once the replica count reaches 4, the VPA weight is given 100. So we scale only vertically in that case. So this was an introduction about HVPA. Let's see some demo. Okay, so I'll first show what HVPA object I'm going to create. Uh, so this is the spec. My screen is visible, right?
Yes.
Cool. So in under HPA spec, part of the spec, we give the scale down stabilization duration of 1 minute. I've kept it minimum so that we can have more dynamic and small demo. So, and update policy is set to auto, and for scale up, we have set stabilization duration to 1 minute and update policy to auto. And then we have the HPA, actual HPA spec. The selector part is given, so because HVPA creates HPA and it uses labels and selector for maintaining that HPA. And the HPA spec is given in a usual HPA spec fashion. Basically, min replicas, men replicas, and the metrics that are supposed to govern the scaling horizontally. Uh, then we can give a maintenance window. I have kept it very short so that it doesn't coincide in any way from with any of the demo that I might give. So it's a standard template that I am using. Uh, then we have the replicas, which is basically the scale sub resource. This is a part of scale sub resource that HVPA implements. We have a target ref set to a deployment, that is resource consumer. And then we have a, VPA template similarly, which has the limit request gap scale parameter to govern the scaling of the limits. Then we have for scale up and scale down. So for scale down, we have the min change, which I have given as 100 millicore and 100 megabytes, just as some small values for the demo. And the update policy is set to auto, and for scale up also similar values. Uh, so, and also I have given the weight-based scaling. So from 1 to 7 replicas, the weightage given to both PPA and HPA will be 50%. So basically, whatever the recommendations are given, we take only 50% of those. And when the replica count is 8, in that case we give the VPA weight as 100. So basically only vertical scaling at that point of time. So what I'm going to do now is, okay, let me just start. Here I'll be starting the HVPA controller. And as of now, there is no HPA in the system. And no VPN. And what I'm going to do is create-f HVPA. So now we see that HPA is created by the controller, and this HPA we are going to follow here. And there is also a VPA that is created. So, and we'll see what pods are running in the system. We have one resource consumer deployment running, one pod running. So we'll monitor the state of these pods, and also what is the usage, CPU and memory usage in this window for this pod. And here what we'll do is we'll just keep a watch on the scale sub-resource of HVPA. So now we see that the HPA is seeing 5% and 0% of memory and CPU, and the recommendation right now is 1. And what I'm going to do now is I'm going to run this run this command, so that which goes to the resource consumer, and it starts consuming 100 millicores of CPU for 1000 of seconds. 100 millicore might be small, so I'm just going to make it 600 millicores. Right now it is almost 0 millicores, using almost 0 millicores. So, so in some time we should be seeing some more CPU usage here. Meanwhile, we'll keep a watch on HPA and its recommendations. And so once the CPU usage increases here, we should see some magic happen. Okay, so the usage has increased to 508 millicores, and HPA should be able to get the data. And so we see that the usage has increased. Let's see what is HPA recommending. So I'm going to dump the HPA YAML to get the desired replicas. We see it is made to 4, and this HVPA scale sub-resource is also increased to 4 now. And since only 50% of weightage was to be given, there is a delta of 3, in which case we take half of that, that is 1.5 delta, and we take the ceiling of that. So HVPA has increased the replicas only by 2 and not by 4, for example. So and since still the HPA recommendation is high, it has scaled the HVPA sub-resource to 8, but we have not scaled the deployment more than 3. This is because of the stabilization window that we had just talked about. So if we look at the HVPA's status, in that case, we can see that there was some last block scaling. And the last block scaling was due to the reason was stabilization window, and what was blocked is also provided. Basically, the current replicas to desired replicas. This scaling was blocked last time. So just a second. Yeah. And since the stabilization window was just 1 minute, after 1 minute, we see some more scaling. So later the scaling was made from 3 to 6. So this is how HVPA can control and stabilize both horizontal and vertical auto scale. So yeah, that was all from my side. Any questions?
Do you have some best practices how to configure that? I mean, there are a lot of parameters and it looks a bit complex.
Yes. So as of now, there's no document that something that documents what might be the best practices, because it is dependent on a lot of things like the application itself. So for example, in even in our deployments, control plane deployments, QPPS and HTD are worlds apart in how they can scale. So right now API server can only scale, HTD can only scale vertically as of now, or at least that's how we want it to scale. So parameters are going to be looking completely different than how we want the QAPI server to scale. But we do have in the HVPA controller page uh, different examples explaining how different parameters behave. So it's quite helpful in my opinion.
Okay.
In fact, you're welcome to have a look at it and maybe suggest some more changes. I'll add some best practices also as you suggested. But yeah, this has some examples. It takes some examples and explains how what kind of scaling might happen with what kind of um, parameters.
I mean, we have two scenarios where this Amshu, am I audible?
Yes.
Yeah, I'm sure.
We have two components for which we are using HVPA right now, though in future we could also think about other resources, mainly API server and etcd, and maybe that is something that can act as an example for two different kinds of use cases, as Gaurav was saying.
Yeah, I think that would be
The
good to
idea
have
was,
some examples which work.
yeah, sure.
Of course,
So,
it depends on the app being
yep.
scaled.
So the idea of putting all these things in the spec of the CRD itself was because the scaling is very much dependent on the components. So of course, but the most common use cases that we are using right now could certainly be a good starting point.
Thank you.
Hi, can you hear me?
Yes.
Yeah.
Okay, great. So in this demo, there was only horizontal scaling involved, right? Or did I miss something? Where was the vertical scaling? Maybe I overlooked.
Yeah, there was vertical scaling also that happened. So I'll just share the terminal again. So if you see the age, right, it's going through it's continuously going through vertical scaling also. Since you see the age is just 50 seconds, and this is because I have kept the stabilization duration very less, and I had given high CPU usage. So there was vertical scaling also involved, because of which the deployment went through a rolling update, and that's why we see the age of these pods very less. And
We could
this
also
can
show
also see.
you could show the status of the HVPA as well as maybe the pod resources part.
Sure. So this is the status of HVPA also contains the last kind of scaling that happened, and here we see the last scaling status, the HPA status, the HPA or the deployment was scaled from 7 to 8 horizontally, and the vertical scaling happened. So vertically it scaled down to 25 millicore because we had spent some time, and I have updated my VPA recommender image so that the scaling recommendations also come in fast, because VPA has a long time, half decay time for it.
Okay, and can I also here see from where it scaled down? So because here in HPA I can see it scaled from 7 to 8. Do I have the same information for the VPA?
This currently is not a part of HVPA code, but yes, it's a good
Not in the
suggestion. We can keep
status,
it
but there are metrics for both the blocked scaling as well as applied scaling. So there are metrics which can be scrapped, which is actually currently scrapped in the seed Prometheus already, which could tell us a clear picture about what was the value before and what it scaled to, or what was not allowed to be scaled in the block scaling. So block scaling is a separate metric and applied scaling is another metric. So you can get that insight from there.
Okay, thank you.
Are there any other questions? Seems not to be the case. Then we can move to the next topic.
Yeah, I'm ready
Hi,
now.
George. We can take this recording and send it to Zoom.
Now we see something.
Yes.
Now it's there. Yes, you found the right setting.
We see the droid. Cool.
But now you're probably muted.
Some magic was required.
So I unmuted you, George.
Oops. One sec.
Yeah, we hear you.
Okay.
Now you're all set.
We hear you.
Cool. Yeah. So the question is, what does it do? So this whole session explains what it does, and it is used to deploy and manage etcd. Now, you might ask then, we already have a stateful set, a service and a script inside a config map that does the trick. So why do we need it then? The plain answer is deploying etcd is not the same as managing it. We deploy etcd, we rely on stateful set to keep etcd up and running, but there are other tasks that has to be performed when we talk about managing etcd. So what does Etcd-druid do then? So I'll take you to the feature roadmap. There's an extensive set of features of which we have partially started on it. So Amshu has created a roadmap. So can you all see the GitHub page?
Yes.
Affirmative.
Yeah, cool. So here I'll quickly run over the main component, main tasks that the Druid would be doing. So initially, what we have done is we are migrating the stateful set deployment to deploying Druid, and we have a resource CRD called Etcd, which would have all the details that's required to deploy Etcd. So this would deploy the stateful set and the services and the config maps, and it would do the tasks of adding finalizers so that it doesn't disrupt the Etcd deployment. Secondly, what it does is it propagates the defrag schedule so that we do defragmentation of Etcd data at the right time as per defined in the spec. Third, it would be used to trigger a full snapshot when hibernating Etcd or scaling down Etcd. This can be used when we would be performing control plane migration, so that when Etcd is brought down, we'd have the latest snapshot to scale it up at the after migration. The fourth one, what we would be doing is we'd be compacting backups. Currently, what's happening is we take a full snapshot and then we take delta snapshots. Currently, every 24 hours, we take a full snapshot, and every 5 minutes, we take a delta snapshot. So there is this period in between 5 minutes, which is like a black hole where we don't, before we take the delta snapshot, we would lose the data. So if we are to reduce this granularity, then the downside of it is we would be having more delta snapshot files, which we would have to replay when we do a restore. So the more the files, the more it takes to restore it. So there will be a job that will be running separately that at regular period of time, it will take the full snapshot, take the delta snapshots, compact it to a full snapshot. And this wouldn't be done, this would be done in a different path than the Etcd, because so that there wouldn't be any performance impact on Etcd. This would drastically reduce the restoration and restart time of Etcd in case of crashes and data corruption. Then another main reason why we would need Druid is to scale up Etcd for certain tasks, like if we are upgrading etcd currently, because we are running a single node etcd, we would have to bring down etcd and then update the etcd version and then bring it back up. This would have a sizable downtime. So if we are going the multi-node way, we could horizontally scale the cluster, etcd cluster, upgrade the etcd, and then bring down the etcd cluster, scale down the etcd cluster so that it is non-disruptive. Another main reason for scaling up is, again, if we have to do vertical scaling of etcds. Currently, the way scaling is done, the pod has to be brought down and then it has to be restarted with the increased resources. In case if we are doing horizontal scaling and then we do vertical scaling, then we can have a non-disrupted etcd scaling. Another task that we have Etcd-druid to do would be when we would be health verification of the backups in the bucket. Currently, what once we take the backup to the bucket, we are not having any mechanism where we check if the backups have been uploaded correctly, whether it has been done without any changes. So what this would do is it would be like a different job that verifies the backups that are currently uploaded to the bucket, so that if there is any anomaly, it can trigger a snapshot. So these are some of the road tasks that we have pending. Now let's, if there are no further queries regarding this, then I can proceed with the demo. Cool. So so this is what an etcd resource would look like. It would have three fields. One is the backup field, one is the etcd field, and inside the backup field we would have the store field. So the etcd field would have all the information associated with etcd. What should be the defrag schedule of etcd? What should be the image? How would the metrics be collected? What are the resources that's required in the etcd pod? Then the port details and the TLS details. Then we have the backup field, which contains information about the snapshots, how the snapshot should be done, what is the full snapshot schedule, what should be the delta snapshot period, what should be the chunk size of each delta snapshots. Again, resource allocated to the sidecar, the ports associated, and the store field contains information about the bucket, the prefix of the directory in the bucket where the snapshot is to be stored, the provider, and the secret to access the bucket. So currently I have Etcd-druid running. So what I'll do is I'll apply I have etcd applied. Now if you do kget pods, we have the stateful set that's creating this pod. So this is the pod that's created by the stateful set, which was deployed by Etcd-druid. and it has the backup sidecar container, and it has the etcd container. It takes, this is the snapshot details. It takes, this is the directory where it takes a snapshot. It does exponential garbage collection. This is basically how the snapshots are deleted from the cloud bucket. Then we have information about okay, storage and store. Okay, and this is the bucket where it would be taking the snapshots. So let's see if the pod's running. Yeah, the pod's running. So okay. Etcd is ready to serve the request. Now, if we take the logs of the sidecar, it has taken the full snapshot. And let's check. Okay, this is the bucket. Yeah, we're taking, is the prefix. So let's see if this prefix is there. Yeah. So it has started taking the snapshots. This is the latest snapshot. It has a full snapshot, which is taken. And then these are the incremental snapshots. So this is a relatively new project, and hopefully going to be integrated into Gardener soon. Yeah. So that's about it from my side. Any questions?
George, can you talk about the integration aspect with the Gardener? How, for example,
How
does it get integrated with Gardener?
Okay. So basically, okay, good. How it'll now be deployed with Gardener is, earlier we had this charts that had information about the stateful set, the services, and the config map, and HVPA details associated with etcd resources currently. So now what it'll do is it'll deploy Etcd-druid in the garden namespace, which watches over all the etcd resources that would be deployed in different shoot namespaces in the seed. And for each cluster that we are creating, we would deploy an etcd resource for etcd main and another etcd resource for etcd events. The Druid will act upon these resources, and it would create the necessary stateful sets, necessary resources associated with etcd. Currently, because it has not gone into Gardener, I have not prepared a demo associated with that. Maybe once it goes into Gardener, we can schedule one more where we can talk further about the integration. But the overall picture is, instead of deploying the overall all the resources from Gardener's side, it would just deploy the etcd resource, and Druid would act on it. Yeah. Cool.
Any other questions?
Can you also configure the grace period for the backups and how much storage you give them? I mean, you make the exponential backup, but for the buckets?
For the storage size for the bucket,
Uh-huh.
at this point of time, because it's a cloud bucket, I guess it's limitless. You can keep on adding to it, right? It's not stored it's stored to S3 and blob storage. So basically, we haven't worried about sizing
Yeah,
these
it's
buckets.
pretty cheap, but yeah, I just meant.
No, but I think there is another policy also. Exponential is not the only policy. I think there is a limit-based policy also.
Oh,
Which
okay.
Yeah.
many objects can be kept in the bucket. It will just basically remove everything, anything over and above that. But of course, it is not still based on a fixed size. It is, I think, still based on the number
Policy,
of backups,
Yes.
which is not as good as somebody might want control on. But still, it is something.
No, so am I audible? Shreyas here.
Yes.
Yes.
Yeah, so right now there are two configuration options possible for the number of backups that you want to keep. One is limit based and one is exponential. Other than that, we also can set the limit on the size of each backup itself. Say if each snapshot is going above, consider say 100 MB, then we write that snapshot to the bucket and start taking a new snapshot with the new revisions of Etcd.
And if it is limit based, then there is another configuration for maximum number of backups. So what is the limit actually? So that basically takes care of how many backups are there, and that plus the size of the backup configuration can give some control over how much is the size of the full backup for that Etcd.
Thank you. That answers my question.
That can be tweaked in the garbage collection policy. It can be limit based or exponential.
Most of these configurations in the Etcd-druid have been taken from the functionality that is already there in the backup restore. So we are fully reusing the backup restore as it is, just exposing them via the CID and then add anything that is additionally required for coordination. So whatever the Etcd backup restore was doing, it will continue to do, and that is exactly what is being taken forward.
Hi, this is Daniel. I would have another question. Thanks for the presentation so far. It was nice. Would it be possible to use the backup and restore or the Druid to back up my local HCD, for instance? Or have you tried that out, or is that impossible? Because, for instance, if I update my Docker for desktop or something like that, sometimes I have to manually back up my HCD and then restore it. Is there a possibility to use the backup and restore, for instance, as a local provider and making these backups on my local machine or something like that? Or
currently, we haven't coded up the feature where Etcd is separate and the sidecar is deployed separately, interfacing with the Etcd. Currently, we have it as a pod where Etcd and sidecar is running, but definitely if that's a pressing need, then it wouldn't be difficult to implement. Basically,
I think
we should have we should be able to communicate with the Etcd pod to take the backups regularly. That can be tweaked. That can be provided in the sidecars.
Yeah.
No, theoretically, it's already possible if you deploy just Etcd backup restore as a separate pod and provide the Etcd endpoints that are already there in the running Etcd. And if
but
you
we
configure,
haven't tested it yet.
No, we haven't tested it.
Yeah,
right.
I mean, technically, I mean, I'm not sure what the question, the background for that question was. I'm not sure if it is for the local development setup or something like that. If that is the case, we could even think of, for example, running Etcd-druid and creating the Etcd CID for that, the local Etcd backing the virtual garden API server, and technically that should be able to restore it from the bucket.
I think
it should be possible, though of course we have not tried it.
Etcd Docker desktop Etcd.
Yeah.
So that's deployed as part of Docker for desktop, but over which we don't have a control, right? But maybe we can have a different pod that has sidecar that talks to Etcd endpoint and takes regular snapshots. Restoration is tricky because here we assume that the volume is shared by backup sidecar as well as Etcd. In the other case, the backup sidecar has not mounted the volume that Etcd would eventually be using for restoring. So that part's a bit tricky, but yeah, it can be worked on.
Not just that, but also because right now we run the bootstrap script within the Etcd container, and we won't be able, if we don't want to touch the running Etcd of Docker for desktop, then that might be a bit tricky for the coordination aspect.
So I think for this local setup, I think this is what Daniel means. In case you're using Docker for desktop, we deploy a separate Etcd that has all the shoots and so on, and this is easy to customize because you have control over that. So I think it should be valid.
Is already doable. We have not tried it. I think this part, what Daniel and you're saying, I think should be possible already, though of course we have not tried it.
On the other hand, it also, I'm not sure if you can also provide a separate account where you back, because now we're going to use the dev account for backing up local development, which is, I'm not sure if the best idea. And I don't think this is this. So where would I specify the account of my S3 bucket, or in that spec, or is it?
It's provided as, you can provide it as a secret here.
Okay.
You have your AWS credentials here, and you have a container, which is basically the bucket, and the directory inside the container where you want to.
Okay, so you're not reading it from the shoot namespace in the seed. You're providing it to the spec directly.
No, it's as a secret ref. Yes.
Mm-hmm. Yeah.
And if you want to choose to back it up locally to your own development machine, then you can always set the provider as local instead of AWS or GCP.
Yeah, local or
just provide the directory name.
Yeah, local. Correct. Local.
Ah, nice. Okay, great. Yeah.
Maybe we can also discuss. I'm interested in it because also for the other type of setups, we still have this problem that is not backed up the local development. If your computer gets destroyed, not if your Docker for desktop restarts or updates or whatever.
Druid, we are thinking. I mean, when I told we're doing it for multi-node Etcd, it can be within the same cluster, or it can be in 3 different. If we are having a 3 Etcd deployment, it can be in the same cluster, or it can be in 3 different clusters, like how it would be for garnering. So Druid would be a central component that would then manage the communication between Etcd, so that.
Swapnil is working on the multi-node within the same cluster part.
Yeah.
I think he has made good progress there. He's on vacation. Once he's back, I think we'll see some closure there. And for the garnering part, I think the pieces are there, but we will need some more additional gluing pieces to make it work across controller across the clusters.
Nice.
Thank you, George. We are already on top of the hour, so I think we conclude here and see you next time. Thank you.
Thanks.
Bye.
Bye.